Hi, everyone. Welcome to Bay Coding Club webinar about the first robotic competition. Here today, we're honored and to invite our very excellent teacher, Paul, here for doing this speak for you guys. And let me introduce Paul Pachikara here a little bit. He is our very excellent teacher. He has taught the Java class, and he is going to teach the robotic class and the robotic club. And he has a lot of experience about first robotic competition. And today he's going to present some of his experience about this. Before he starts to speak, so let me introduce a little bit about Bay Coding Club. Very quick. So Bay Coding Club is a leading cutting edge of K-12 technology and mathematics academy located at the Silicon Valley. We do franchise. And we're about to open our offline classes at Cupertino at September. And we offer dynamic classes, mainly focus on the technology part for K-12. And our team, including the staff and the teachers, came from nationwide in the United States. They are maybe the senior technology engineer from Google or Apple, all the professors from very top universities such as Stanford and MIT. And we also have a very good partner from some of the local universities such as SUNY Albany and some of the university at other states. And our teachers, we selected very carefully, and they all has a lot of experience about computer science. And right now we only have English class. We don't have any Chinese class, but we're about to open the Chinese class maybe in the future. Yeah, this is part of our roadmap about Bay Coding Club. Actually, we established at upstate New York in 2015. And after some of development years, and we moved to the Silicon Valley, and we changed the name at the beginning, one called toFRC into Bay Coding Club. Right now, we have almost 30 teachers, and we have about 10,000 of students nationwide. And here is a little bit about me. My name is Ruby San. I'm the founder and CEO of Bay Coding Club. And I'm a mom of a 10-year-old. I work at information technology field for more than 20 years. And I teach computer science basic at our community at Cupertino. We have a dynamic of the classes, such as we have a programming languages classes, and we have a competition-based classes such as USCO, AP Computer Science. And we do have any other course designed by the kids who love design. Design including game design or the design of UI design or UX. And we have summer camp, winter camp, and other camps during the spring or autumn. And here is the snapshot of our website. You can log on our website at baycodingclub.com to look up the information about our classes. And we provide group classes, which means 8 students in one class, one teacher. And we provide semi-private classes. That means 2 or 4 case, one teacher in the class. And we have one-on-one classes. That means 1 teacher and 1 student. Some of the parents and kids ask us, how do you know where should I learn? Where should I goes for? So we design a lot of pathways for kids. We design case like game design. We design the the game design for them, or some of the students like web design. We design the pathways for them to learn, even from kindergarten and to high school. If you want to learn the web design, we have that course for you. And we also have the competition-based, such as USACO. USACO stand by United States American Computer Science Olympiad. And this American Computer Science League is ACSL. Last year, our team won one gold medal and the other one silver medal, and our whole team won the first place. Here's the web page of our ACSL. You can just log on our website and to look at it. And this is our new opened robotic club, which that teacher Paul will teach, will just be your coach every week actually. And he also have the regular robotic class. You can take a look at our website. And yeah, here is the information that I want to provide to you guys. And you can just shoot us the email at info@BayCodingClub or call us. We have the fall registration opened. So if you're interested in any of the class, you want to register a new semester, you just log on our website. Okay, here I gave the time to the teacher, Paul. Hi, Paul. It's your turn.
Hey there. Can you hear me all right?
Yeah, you can share a screen.
Awesome. My name is Pachikara. As currently stated, I'm a Java teacher and the robotics teacher and the coach for the robotics club at the Bay Coding Club. I'll be just presenting on first robotics competition, also just how to get involved with robotics. And yeah, let's get started. So the first couple things is just what I'm going to cover. First up is, what is a robot? I think there are a couple of misconceptions on this, and I just want to clarify that. And then, what are some examples of robots? Robots are found in a wide variety of spots in our lives that we may not even know. And then a third one is, how are they made? Because there's a very standard process to how a robot is made, and how to get into robotics. And how did I get into robotics? How can you get into robotics? So first up, what is a robot? Well, this is the definition from Encyclopedia Britannica. A robot is any automatically operated machine that replaces human effort, though it may not resemble human beings in appearance or perform functions in a human-like manner. This is a very formal definition. It's a mouthful. It's hard to think about. I don't like it. So this is my definition. Robots are just another way to express your imagination. Their purpose is simple, yet their use is broad. They can just beep or boop, or they can do so much more. The only true similarity between all robots is that they're there to solve a problem. That's the only purpose of it. The only reason why someone would take the time, the effort, the money, and the resources to make a robot is because they have a problem in their life that they can't solve with their own human hands. So, what are some examples? So this is more like a standard, stereotypical kind of robot. You got like the lights, the bolts, the different like metal-like bodies, and like the weird stringy arms. And these robots, they're fun. They're interactive. They are there to entertain. And another good example of some entertainment bots, well, although they may or may not be more realistic, is the bots we see in movies. So for example, these two from my childhood, the Iron Giant, great movie, and WALL-E, just one of the best movies I've ever seen in my life, are great examples of robots. You have the Iron Giant that defends a town against a nuke, if I remember correctly, and you have WALL-E, who falls in love with another robot. And these are all movies that push boundaries on what a robot could be, what a robot can do. And then you have things like Star Wars, which kind of depict the future of what robotics could be, or Terminator, which also depicts the future of what robots could be. One, you have friendly bots. One, you have a robot that's trying to kill you. It's all there. And robots, in that way, robotics is very broad and what is possible and what can be done. There's also other good examples of this, like Transformers or Gundam. The list goes on. So this is so far, as at least is released to the public, the closest human-like robots that we know. So this is Atlas. It's from Boston Dynamics. It's taken millions, if not hundreds of millions of dollars to develop this thing. But what it can do is it can move like a human and very accurately. It can do very crazy things at times, like a backflip. It can dance. Other robots you see here, these are other robots designed by them. And it can move around like a normal human being, which is truly impressive. The one thing I would like to preface is that with robotics, the robots are there usually to take on a task that a human finds hard to do. So this includes like very repetitive, very arduous tasks that like go beyond the human body. So like you need to lift a heavy object, use a robot instead of a human, because humans can only lift so much. But then humans, on the other hand, there are many tasks that humans find easy that robots find very difficult. It's like creative thinking or moving around in a very organic way. These are all things that that humans can do that robots can't do. They're very difficult for a robot to do so far. And so then we get to robots as toys. And this Mindstorms, not this exact set, but the older Mindstorms is how I personally got started in robotics. It's a great way for kids to get into it. Here's another robot. I think its name is BMO, and BMO is this programmable robot you can play with, and also has its own predetermined functions to it that you can use. On top of that, there are these are like remote controlled toys, and they're fairly close to robots. They're not exactly robots, but they interact with their environment by just driving around, making noises, and doing all kinds of crazy things, and you can control them. So in my personal preference, they're pretty close. So now we get to the real life applications. The one thing is, as I tell you about these applications, I'd like you to think about what kinds of problems these robots are trying to solve. Then we'll go over it. So with the first application, we're in a car factory, and we see that there's these massive giant arms. These arms are there to obviously build the cars, but not on top of building the cars, they can do this task for hours, if not days or weeks, as long as they have power and they don't break down. The third is that they're very durable. They can handle a lot of damage done to them that a human could not. And then fourth is that they're much stronger than humans. So they can like lift up like several thousand pounds of metal, which in this case would be like a car body or a whole car. Then in our second example, we have a driverless car. So in this case, you have people using robotics to figure out ways for cars to drive themselves. It seems almost unnecessary because it is a very complex task. Because driving can be very unforgiving, can be very unpredictable too, and so they're using like a whole like set of like an array of like different sensors to help the car interact with the road, figure out where it has to go. And so in our third option, we have application. We have a Roomba bot, and this is very much unnecessary, but it's for those people who want someone else to do their vacuuming for them without having to get someone to actually do it. They pick a robot. They programmed a robot and they figured out what to do. The fourth one is a 3D printer. this case, the printer is there to make these very complex shapes. As you can see, you have in the image, you have all of these, you have this very like complex statue. If you were to do this with the regular tools, either you would have to, you would probably use some kind of mold or something, or even older speaking, so like a couple hundred years back, you would use a chisel. And I don't know if you know, but if you've ever gone to one of those, like a museum, a famous park, some kind of palace or something, and you see like these kinds of statues made out of stone, that might have taken them days, not weeks, to do that. And this thing can burp one out in like an hour or 2 hours. This is why people use robotics for this. And so, and then with this, you have a CNC machine that's machining out a part. And so they have, you can see that they are, they're using robotics to have precision parts and do it very quickly, at least much quicker than what a human can do. And then you have, this is another toy. This is Optimus Prime. You have, this is very much an unnecessary application, but this toy can fully transform on its own. It can do it automatically. This is something that if you were an enthusiast like me, you would fully appreciate how impressive that is to do. Because it's about, I think it's 18 inches tall, and you have, and it does the entire transformation. And so then looking at our next application, this is more of a medical application. You have a mechanical or a robotic prosthetic. And this is for people who have lost a limb through like disease, an accident, war, things like that. And they want to still function like a normal human being. So here is an arm. Here's like a robotics trying to come in and build or replace an arm to the best of its ability. Obviously it's not perfect, but it has a lot, I'm sure it has a lot of sensors that help the human being interact with it so that it can work like a normal arm. So in all of this, we have 7 different applications, but the thing that I want to preface is that there's one grand similarity between all of them. And that is that they're all trying to solve a problem, whether that problem is necessary or unnecessary. And they're trying to do it because there's people out there who's always been trying to figure it out. And so they use robotics to figure out to solve the problem. So to go back to the applications, factory managers wanted to optimize their factory lines. So they want to get cheaper. They want the cost to go down, want to have cheaper labor. And so they use robots to do that because they didn't have to pay for wages. The robots don't go on strike, and they're much more durable, as I said before. And so they chose the path of robotics to complete the task. And they had a problem, and the problem was solved through robotics. Obviously, it's not completely solved. Robotics always is innovating like that. In our second application, we have the problem of dangerous driving. And people have always thought that if you could control the way that like every car drives, then it'll be much safer. It'll be a much safer driving network. And on top of that, it might actually decrease traffic because everything is happening all at once. And so you have, so they chose the path of robotics, solve a problem, and see how far they get. And so as there's been like, obviously Tesla's coming out with their own driving system. Google's working on it. I believe Facebook is too. And then you have people, and then you have the third application, which is the Roomba bot, which is that people didn't want to vacuum clean, and they didn't want to hire someone to vacuum clean for them. So they decided to get a Roomba, or they decided to get their own personal assistant, which is as a robot. And this is what they come up with. It's a robot. With the fourth application, people wanted to figure out how to build very complex shapes and do it in a very non-time intensive way. So they went through, they did like a whole design process and came up with a 3D printer, which is a form of robotics, or the CNC machine. They wanted, it's almost like the the 3D printer, but it's for metal parts. They wanted precision and they wanted accuracy, and they wanted to do it in a very time-effective way. And so with robots, they put down the costs. They made more precise parts. They might have made stronger parts too. And then with Optimus Prime, obviously, as an enthusiast like me, I'd love to have a figure that looks like the actual robot from the show. And so through robotics, they used different servo motors, different sensors, different like microchips and whatnot. And they came up with this guy, this figurine, which can fully transform on voice activation. And then you have people like this, victims of violence, victims of war, victims of accidents. And they still want to live their normal life. And unfortunately, because of the events that happened, they can't without the help, without finding some kind of replacement to their arm. And because of that, they went to robotics to solve the problem of trying to get back to their normal life and trying to build an arm again. And so through all this, these are very different robots. There's like, if you were to like, you can't like fight them or anything like that, but you can compare them through that process alone. That is my point. So continuing on this point, how are they made? There is the process. All robots are different, but they're unique because they're all the same in how they were made, as I stated before. So with this process in mind, let's go through it. First, there's only 4 steps. First is to define the problem. So you want to figure out what you have to do and what you can do. Then off that, you want to brainstorm, figure out an idea that may work, then prototype and test that idea. And if that idea works, then you assemble it. You figure out, you use that as your final robot, and then after that, you're on the home stretch and you use the robot. So going through it, let's go through defining the problem. So know what problem you're trying to solve. If it requires to do it in a certain way, then figure out those requirements. This step right here is a very important step. You do not want to get the step wrong, because this is like the foundation of knowing what to do. Because if you find out, if you're in the prototype stage or in the final stage, and you realize you missed a requirement, or you missed something, or something changed, then you'll be out of luck. You'll have to restart the entire process. Because you'll find out that your robot, like, it doesn't work because it's doing it in the wrong way, or it met a different condition when it was supposed to meet this condition, something like that. And so standard requirements, especially in the real world, or even in things like FIRST Robotics, is time. So with FIRST Robotics, the FIRST Robotics competition, you have a build season. That build season only lasts 6 weeks. So you have a certain amount of time for it. You have to build the entire robot out. And then you have, with FIRST Robotics, you have a budget. You need, what was I gonna say? You need to find funding for parts. You need to then, and you need to make sure that the money you're spending, you're not spending in a very inefficient way. And then on top of that, with most of these robotics competitions, you usually have like a size constraint. So like in FIRST Robotics, I believe the size constraint was couldn't be more than like 3 or 4 feet wide. No, 3 feet wide, like a meter wide and a meter in depth. And because of that, people had to constrain the robots to do the challenge. And usually these requirements are just things you have to work around. They're usually not like things that'll completely hinder you from doing the robot. And so then on top of that, there's also other requirements of like the robot has to somehow interact with the field. So in this case, you have a next robotics competition where the robots have to have parts that can be used to interact with these balls, or interact with and like put them into these nets. And so those are also requirements. They're more so the objective, but you could also think of them as requirements to solve. And then next is brainstorming. So this part is where once you know what you have to do and what you can and cannot do, it's time to actually start figuring out what you're gonna do. So with this, I personally recommend start off easy, make simple sketches, just jot down ideas and figure out like very raw like ideas that may or may not work. You may not know. And then if you want to be, and then once you have like a couple ideas or an idea, just maybe a singular idea, if you can't think of anything, then flesh out that idea a little more, draw it out, or if you want to go into a CAD program or a computer aided design program and make a model out of it. So if you have here, this is like more of a kind of advanced design. It was like, I wouldn't say it's the roughest sketch. It's definitely still a rough sketch. And then you have something like, you have a CAD model like this, where where you can see like the different parts and you can view it from different angles. On top of that, with the bonus of having CAD models is that you can change the model. So like you see this one screw hole, maybe it's too small. So you can quickly just widen it a bit, and then you have the finalized product or what you want. And so with like if you had like a hole here that's too small on the picture, then you might have to like erase and figure it all out again. It'll get dirty, and it won't be as clear anymore. So yeah. So once you come up with an idea, make that you think might work. Then it's time for the next step. That step, excuse me 1 second. The next step is prototyping. And so this is where you get to test your ideas and see what doesn't work. There are various ways to test it. The two biggest ways is to use a CAD model. The CAD model you came up with in the last one. So like, say you have a part here, you can then use some kind of simulation program to test whatever you need to test. So whether that's like practicing in a, like checking if the arm will move, if you have an arm and you want to like check if it's going to move in like a particular way, or test if it can grab an object and then throw it, or like in this picture, you can like stress test some kind of part and see where it's going to fail and where it's going to be all right, and go from there. Or you can create a prototype. So this is like a very rough sketch of, or not, sorry, very rough model of a chassis. And this probably took 2 hours at most to whip up and make. And you can use based off your previous brainstorm, you can use this to test your ideas. And so if you have a couple of different ideas, you can use this to test the ideas and see which one works best in your opinion, and which one maybe it doesn't even work. Maybe it fails. So you don't use that idea and you move on. I would say this kind of process is more like a very rational based design process. So just see what works best and what doesn't, and then move on from there. It's a very simplistic beauty of it. And then once you have all your parts, you assemble it, and you do this is the stage where you actually put in a lot of work to try and get a finalized project or product. And so if you need to use more advanced parts, then you can you use it. So obviously in a prototype, you would use like very cheap steel. But then if you want to strengthen the chassis, then you would probably use stronger steel, or like, let's say you used aluminum in this stage, use steel in the next one so that it's stronger. And it doesn't waste as much many resources, doesn't cost as much. And that's how you would do it. Obviously there's other things too. Like you can, for a prototype, you'll just keep it very bare, but then with your final project, you could actually make it look kind of, you could pretty it up. So you could paint it, you could put on some design, you can put on different like etchings into it. If you want to do that, that is usually a standard practice in FIRST Robotics. In the FIRST Robotics competition is that you'll have a prototype bot and then you'll have a final bot. The final bots will look they'll look very cool because they'll have like paints on them, or they'll have different kinds of designs and like sponsors and whatnot. And it's quite a sight. And so yeah, that's basically the process. So as stated before, you just have to define the problem. You got to brainstorm it and figure out ideas for it. And then you got to prototype each and test each idea that you brainstorm. And whatever idea you came up with that works from the test, then you just use that idea and assemble a final product. And you should be on the home straight to use that robot. So now get on to our fourth and final part. So getting into robotics. How did I get into robotics, and how can you get into robotics? So with me, my parents bought me the original Lego Mindstorms set when I was in third or probably second grade. And this was probably in like 2009 or 2008 when they did this. And so at that time, I loved Legos. I still do love Legos. I haven't built a set in years, but then at that point, I loved Legos. I whipped it open. I tried a couple of sets. As how Mindstorms works is that you have, if you've yet to play with Mindstorms, you have, they give you a couple of like sets that you can use to get used to it and figure out how like different sensors work and how to program it. And then afterwards, you can do whatever you want. And so with that in mind, I did all like the presets that they gave us. And then my dad found like these private Mindstorms competitions. Like they're not like the first Lego League. It was these competitions hosted by, I think, just a group of people. He might have found it on like Facebook or something, or like heard it from a friend. And that competition, we had to build a sumo bot. So I went through the same process. I was like, I had to figure out what my I had to define the problem, figure out my requirements, and then I had to brainstorm. What I came up with was that I had a plow in the front to get robots off the ground. I then also had a bunch of tires to increase grip, and then I had battery holsters, so like ways to hold batteries that are heavy to weigh down the robot more. And I did fairly well in that competition. There wasn't any placing, but I think I probably might have gotten like third or fourth. And we obviously ended up getting beat out by this probably like 40 or 50-year-old engineer who figured out that how to mount this plate in a very interesting way. It was cool. It's very interesting to see how the top robots function and what they come up with. And this guy figured out this technique that blew everyone else out of the water. And so this was all in elementary school. But going then into middle school I took part in VEX robotics competitions, and this was run by the robotics teacher. So I was very lucky that my school had a robotics club and a very entrepreneurial robotics teacher who always writing grants, always getting crazy gear, always like when I graduated, he probably had like four or five 3D printers that he had just tried to get. It was very impressive. But in the 6th grade, I was part of a VEX robotics team. We did all right because we didn't really know what we were doing. And then in the 7th grade, I had a bigger robotics team. We did all right. And I don't know if we placed or not, but in the 8th grade, the robotics team split. So I was doing it with 2 other friends, and we did all right. It was one of the best things I've ever done in my life. It was so much fun. And so after that, I moved on to the first robotics competition. This is, if you are, this is only really for high school students. It's meant for very big teams. So like I was probably like a 30-person team, and first robotics competition teams, they're run more like a small business because they find their own funding every year. They then have like, usually they're divided into like separate sub teams of people who are trying to build the robot, program the robot, design, market, and then do outreach. And we had to, and so I was part of the engineering team, and I helped build the robot and design it. And so in my junior year of high school, we got to Worlds, and it was a very cool. It was an amazing experience. We had to we didn't end up we were all impressed that we got there, but we didn't end up doing too well because of one of the parts of the robot that was pretty critical broke, and we weren't at our local shop or at our local place to build the part again. So it ended up failing. But this is what happens in robotics. It's very, because these prototype robots, they're very hit or miss sometimes. And that's just all part of the process. And it was a very eye-opening experience for me personally, because I got to see how like robotics probably scales up from here. You find the funding, you then go through the whole process, and you use these like different requirements, and there's like these different circumstances that you have to face. So that was basically my first robotics competition experience. And then now I'm in college. Because of COVID, I haven't been able to do anything yet, but I'm trying to find, when I get to my college, I'm hoping to find some kind of club to take part in and see where that goes. And so that's how I got started. But how can you get started in robotics? So the first thing is, if your school offers a club, some kind of robotics club, you should join it. And if it doesn't, you should make it. I know that can be a very scary experience, and it'll probably take a lot of time. Definitely, depending on if it's high school or middle school, that might take a lot of money too. But you should I would urge you to try, because you don't know what you could be starting. You could be starting a very good club, a very large club. And then for the second part, you should do robotics related projects and get your like toes dipped in the water of robotics, basically. That's what I did. When I was trying to do the Lego Mindstorms, the Lego Mindstorms at home. I got a chance to like understand how the whole process works, how to design, things like that. And it was very foundational. And then what's it now? If you don't have any of those things, you should try and enroll, or if you have those things, or you don't have any of those things, you should try and enroll in robotics courses. And my middle school, I was very fortunate in having a robotics course at all. I know that there's many just middle schools, even high schools, that don't have a robotics course. So if you don't have that, then you can do more private courses, like at Bay Coding Club. You can come to us, take our courses. There's also other opportunities too. And that could be free, that could be more accessible to you, that could be the style that you are looking for. And so I implore you to search. Anyways, and so with that, you have these three options. There's also probably other options that I couldn't think of off the top of my head, but I would implore you to just start looking in these three ways. And yeah, good luck searching. Thank you so much for listening. My name is Pachikara, and does anyone have any questions?
Thank you, Paul. From the original registration, we do have some questions from the parents. Are you ready for answer that first? And then we can collect some from the chat here.
Sure.
Yeah, one of the parents, they asked, how old do you recommend them to learn that related with the robotics, such as FLL or FRC?
So I would say, okay. So there's there's this company called First. They run this whole like competitions. And so you have FLL Junior, I believe, and you have First Lego League, the normal one, and then you have I never did this competition, but you have a different Lego league that's then for older kids, it's like middle schoolers, and you have First Robotics competition. And so First Robotics competition is only for high school students. You might be able to get in as a middle schooler, but I would just recommend wait till high school and see if your school has a team. And I believe there may be private teams as well that you can join, but I'm not too sure. I've only heard of high school teams. And then for your First Lego League Junior and First Lego League Junior is for probably kids of like kindergarten, first grade, or second grade. And then First Lego League is probably for second grade to maybe like sixth grade. You could probably do it as a seventh grader too. But I would say start small. Don't throw yourself into like something crazy like First Robotics competition, because it does get pretty advanced at times of what's going on and very professional at times.
All right, thank you, Paul. Yeah, the other question is, do they need to learn some computer programming before they attend the robotics?
I would say, personally, I would say you might want to try a bit just to like see. Obviously, I think like my robotics competition. Wait, one clarifying question. Is this for just any kind of robotics course or any kind of robotics club?
Yeah, I don't clarify that too, because I think maybe the parent ask, do they need to learn something before they learn the robotics? Yeah.
So I would say that with most clubs, you will have, it kind of depends on the club and how it's structured. If it's a club at school, usually they'll have ways to teach the kids what to do. So I know that for my club, the robotics competition, or my first robotics competition club, they had like a period of time before build season where they would teach incoming students, like freshmen and sophomores, the skills they needed. And so this is like, for engineering, this was like how to use power tools. For computer science, it was what the code they used and what was there to teach. And so there's that. And I would say before coming into like a club, find out what they use and then just try it out a bit on your own. So if it's a First Lego League club that you're trying to join, then maybe get your own Mindstorms, or I know that that's pricey, but maybe try and get some kind of Mindstorm, or use like the Mindstorms code. Because I know that like for us, for our club, because we're online, we're gonna use the virtual robotics toolkit. So you don't need an actual kit to actually do Mindstorms, but it basically it does the code and it simulates the robot, and it basically does the same experience. So I would say, yes, probably try and dip your toes in a bit, but you don't need to like know everything coming in. That's where you learn from the club and from the course. That's what that's there for.
Okay, so one of the parents asked how much should they pay for attending FRC?
So that is it. That is a complex question, because it's more that you pay for your club fee. And so that really depends on the club. I believe that I don't think it's not the cheapest thing in the world. It's probably like, cheap end is like $50. The most expensive might be a couple hundred. And I wouldn't know for sure. I don't remember how much it costs for me to be in my robotics club, because it definitely takes money to do what we do. And and so it's I don't know. It's hard to say, because it really depends on club to club.
Okay. By the way, can you introduce a little bit Bay Coding Club, Robotics Club? What are you going to present them, or your robotic class? The
Sure.
case, yeah. Mm-hmm.
So with the robotics course in mind, you could almost say that they'll run somewhat in conjunction with each other. The robotics, the course will explain how to use the virtual robotics toolkit. So we will practice on, or we'll go through using or doing coding in the robotics, the coding in the Mindstorms code for the simulation. And then after that, we'll practice building bots, because it can be, it's a bit of a learning curve with all of this, especially with the coding. And then I personally say that it can be a bit finicky at times to use the Lego, the virtual, what's it called, the Lego designer. But we'll go through that. But then for the club, this is more of and then one more thing. The course will have will also, on top of teaching kids what to do, we'll have like different smaller projects that will be based on what we taught, and we'll cover maybe 2 or 3 weeks to do these projects. And then we'll move on and learn something more about the virtual robotics toolkit and what to do. And then so then looking at the club is more so based on like, it's like an independent kind of learning. The kid can do whatever they want. I'm there to like help them or coach them and maybe mentor them on what they can do. And so we'll meet every week, and I can help them brainstorm like problems they can do, challenges they could try. Yeah, that's basically how the club is going to work. It'll be much less teaching involved. So yeah, it's the club. You will want to know stuff beforehand, but the course will teach you what to do.
Okay, thank you, Paul. So there's another question from the parents on the registration form. They ask one of their kid and learn some of C++. Is it helpful for learn the robotics?
In this case, it is not. But well, at least for what Bay Coding Club teaches, it is not helpful, because you can't. Mindstorms coding is very different from C++. It's a much more simplistic version of, or it's a very oversimplified version of coding, because it's block coding. But if you, I guess if that kid is in like high school, he can go to an FRC team, a first robotics competition team, and he can try and do CS for their team, because at least in my team, they used Java to do it, and there was like a very like number of like different like complex math they had to figure out, things like that, and it was all done over like Java. So C++, some of the similar thing, and I don't know if robotics uses C++. They might. Not too sure on that front, because I use Java for Vex Robotics too. So I don't know. You'll have to figure that one out. But if worst comes to worst, you can learn Java too, because a lot of it kind of carries over, at least syntactically speaking. And yeah, we'll see. So that's basically it.
Yeah, so thank you, Paul. So I would ask you if you have any question from Clubhouse or from the Zoom, and you can let me know. You can open your microphone and let me know your questions, or you can type on the Zoom by chat. I will just let Paul answer your questions. And we do have some of questions from the registration form. So one of the case, they attained the FLL for many years. So how they just change into the FLL to FRC? I believe the question is.
Oh,
by the way, can you let me share my screen? Thank you.
Oh, yes. Sorry. Sorry, well, can you repeat the question again?
They said their kid attended the FLL, the local lead, for a couple of years, and they want to change to FRC. I don't know how old are they, but you mentioned FRC should be in high school. So
yes,
they didn't tell me the information, but it is only because the age, or is there any other requirement for the FRC?
Other than that, there is oh, sorry. Okay. So there is one. So the level that I was thinking of that's in between first robotics and first Lego League is this thing called First Tech Challenge. And so that uses it's much more, it's definitely more advanced than first Lego League. I don't think the teams are as big. I never did it myself, so this is why I didn't really know. But it uses like metal parts and whatnot, and it looks like it uses much more advanced coding to do this. So if he's interested and he can find a First Tech Challenge team, he should try doing that. Unless he's in high school, then he should try finding a First Robotics club. But yeah, that's basically all I can give, because again, I'm not too sure. There might be private teams. I'm sure there might be private teams. I never investigated myself because I was fine with doing the Lego, the club at my school. But I'm pretty sure there will be private clubs that he could join and see if they'll accept him, even if he's not in high school yet.
I don't even know the information, so that's why we can skip that. Yeah, I think this question is really good. I picked it to you, and they ask. So they said there's a lot of robotics right now, but it seems like the robotics is not fully functioned and fully developed nowadays, and they noticed that. So I believe they asked a question like this. They said, is there any good relationship between the FRC to the real world of the robotics?
Yes, there is. The thing is that I don't know if any of you have seen Mythbusters. There is one of the Asian hosts there. No, the Asian host there. His name is like Grant Muramame. One of them. He was a First Robotics mentor. And so the thing is that with First Robotics, there's a lot of funding that actually goes into First Robotics from bigger companies. And on top of that, there are companies that will, like engineering companies, that will incentivize their employees to become mentors. And so I like all of the mentors that we had were engineers because I live in the Seattle area. So we have big companies like Boeing, Microsoft, Google, Amazon. So we had mentors that came from these companies, and they were able to give what they thought or their knowledge onto us. And obviously it's hit or miss with some of these mentors. They may be knowledgeable, they might not be good at mentoring, but you have First has these kinds of mentors there to give us access, or to show students like techniques and things that they can do that are brought from the real world into First Robotics. I would say also on top of that, the way that usually a First Robotics team is run is very reminiscent, again, of probably a small business. I'm not too sure. I've never been, well, the only small business I've really been to is this one fundraiser, but that's a different thing. And the point is that I feel like it's a very good simulation for what is to come, and how to like make a robot in the real world and compete. And so in my personal opinion, First Robotics is probably it's probably the best way to do these kinds of, or to get experience before going into a real job.
All right, thank you, Paul. So I will ask Anyone has any questions about related with the robotics or FRC or the tournament of any of the competition? So you can open your mic. Anyone? From the Zoom, I believe. Or you can tap into the chat. Okay. All right. So if you don't have questions, yeah, I think we're good for today's webinar, and we do have another webinar for the next week. You can just stay tuned with us and visit our website at baycodingclub.com. And we're very appreciate Paul today's presentation. And if you have any question, you can just log on our website and shoot us email or call us, because we opened all the new semesters registration already. We have a robotics class, and we also have the robotic club, which you can pay only $10 per week and to attend the activities during our club. And we also will open the on-site school at the Cupertino, California. If you happen to be here, just join us at the weekend. We also have a lot of events coming soon. Okay, thank you, Paul, again. Thank you all for coming. Okay, okay, we're gonna finish our webinar. Thanks all.